Okay, hello everyone. So for today's lecture, we're going to cover on basic law for analyzing circuit theory. Okay, so we have Kirchhoff's current law, which is known as KCL, Kirchhoff voltage law, KVL, Ohm's law, voltage divider rules, VDR, current divider rules, CDR, and star delta transformation. So all these basic law are very important for our first chapter, which is AC circuit theorem. So we're gonna start with Ohm's law. Okay, so Ohm's law defined as impedance Z is equal to voltage divided with current. Okay, so Z is known as impedance, which consists of resistor and reactance. V is voltage and current is in ampere and impedance in ohm. Okay, so let's say we have a series circuit. ZA, ZB, and this is our source. So we would like to determine what is the current flow in this circuit. So I will be V over Z total. So Z total will be ZA plus ZB. And since this is a series circuit, so current flow in ZA, impedance A, is equal to ZB. So for series circuit, I at ZA is equal to I ZB, which is equal to I total. Okay, so let's say we want to determine the voltage drop at ZA and voltage drop at ZB. So by using Ohm's law, we know the current flow at this circuit is equal to I, which is V, the total, the supply voltage over Z total. So if we want to determine VA, we can calculate by using Ohm's law, which is I multiplied with Z. So I is the current flow in the whole circuit, which is I total, and Z should be ZA. And for VB, I total multiply with ZB. Okay, so let's say if we have parallel circuit, what I mean by series and parallel circuit is based on the impedance. For this case, the impedance is in the two impedance is in series, while for parallel circuit, okay, so for parallel circuit, we have two impedance connected in parallel. So for this case, for parallel circuit, the voltage are same, but current is different. Current are different. So let's say this is the voltage supply, and we would like to measure what is the voltage drop at VA and voltage drop at ZB. So in this case, since all the impedance are connected parallel to the supply voltage, so VA is equal to VB, which is equal to the supply voltage. However, if we want to calculate the current flow at this branch and current flow at branch B, so you can calculate IA equal to VA, which is equal to V over ZA. Same goes for IB, V over ZA. So let's say if we have a combination of series and parallel circuit. Okay, so for this case, voltage measured at these two impedance is equal, since these two impedance is in parallel. However, for ZA will be different. Okay, let's hold on this example. Okay, so we already covered Ohm's law, and for now, Kirchhoff's current law. So Kirchhoff's current law defined as total of current in is equal to 0. So let's say this is I1, I2, I3, I4, and I5. So I1 plus I2 plus I3 plus I4 plus I5 is equal to 0. Or current move out, total of current move out is equal to 0. So I1 plus I2 plus I3 plus I4 is equal to 0. Or current in is equal to current out. I1, I2, I3, I4. So for this case, current in is equal to current out. So I1 plus I2 equal to I3 plus I4. Okay. So next, KVL. So let's say we have 3 different sources labeled as V1, V2, and V3. So total of current, total of voltage is equal to 0. So for this case, since we label our loop current flow this way, which is clockwise, so negative V1 plus V2 plus V3 is equal to 0. So you have to be careful with the sign of your positive negative of your source. So since we assume that current are flowing from this way, so V1 is negative, V2 is positive, and V3 is positive. So negative V1 is, plus V2 plus V3 is equal to 0. So we already covered KCL, KVL, and for now we're going to cover voltage divider rules, VDR. So let's say you have two impedance connect to a source which is in series. So ZA, ZB, and this is VS. And you would like to measure voltage drop at VB. So by using Ohm's law, you can actually calculate the current by total up these two impedance. So VS divide with ZT. So once you get your current, then you can calculate VB equal to I multiply with ZB. So this is method 1. So for method 2, you can use VDR to calculate what is voltage drop at VB. So VB is equal to, using VDR, ZB over total of impedance. So ZA plus ZB multiply with VS. Okay, so let's say you want to measure voltage at VB, at ZA, sorry. So ZA over Z total, which is ZA plus ZB, multiply with VS. Okay, so next we're going to proceed with CDR. Current divider rules. And again, for VDR, this method, this law only apply for series circuit, and for CDR only applies for parallel circuit. So this is ZA, ZB, and IS. Okay, so if you want to measure current flow at this branch A, so using CDR, IA is equal to, we take the opposite impedance, which is ZB, and over ZA plus ZB multiply with IS. And if you want to calculate IB, so IB equal to ZA over the total of impedance, ZA plus ZB multiply with IS. So let's say if you have another impedance connected, so means that you have 3 parallel impedance. So if you want to calculate IA, you need to parallel these two impedance. So ZP parallel with the ZC over ZA plus ZP parallel with ZC multiply with IS. And also if you want to calculate IB, so you have to parallel these two impedance. So ZA parallel with ZC divide with ZP ZA parallel with ZC multiply with IS. Okay. And if let's say you have another one impedance connected series with the current source, okay, for this case you know that current in series are the same, so you can ignore this impedance and calculate current flow at each branch using these two. If let's say you have Z impedance at here, or maybe I should redraw it again. Okay, so ZA, ZB, ZC, ZD, and this is IS, and you need to measure what is IC. Okay, so for this case you need to determine what is current flow at this branch, so label it as I node. So you can apply CDR, but first step you need to parallel these two. Okay, so ZC parallel with ZD, then you can calculate what is I node. I node is equal to ZA divide with ZA plus ZB plus ZC parallel with ZD. Okay, and multiply with IS. Okay, so once you get what is I node, then just ignore this and put, since we already calculate what is I node, so you can just replace with current source, which is I node. So this is ZB, ZC, and ZD. Okay, so again, since ZB is connected in series with I node, so we can ignore it. Then to calculate IC equal to ZD divide with ZC plus ZD, then multiply with I node. So you can substitute in what is I node. this one into here and calculate what is IC. Okay. Okay, so we go through the first example. So you need to determine what is IA. Okay, so first step, you need to obtain what is current flow at this branch. Okay, first step, you need to parallel these two and plus with 8. So ZA equal to 8 plus 2 parallel with negative J4. So you can calculate it. 2 plus negative 4J. And inverse back. Plus 8. So 9.6 minus J 0.8. To calculate a complex number using calculator, first step, you need to press mode and select 2 complex. So if you want to parallel these two values, so make sure that you make a bracket for each of the each values. So press inverse plus negative 4J inverse and inverse it again, so you get 1.6. This is for the real number. For imaginary, you can press shift equal, so you get the imaginary part, and plus with 8. So 9.6 negative 0.8. And if you want to change from rectangular to polar, you can press shift plus equal. So this is the magnitude, value for magnitude, and to get the angle, you need to press shift and then press equal. So you get angle negative 4.76. Okay, so to calculate I note, so this is set A and J2, and we need to calculate what is I note. So I note is equal to J2 divided with set A plus J2 multiply with I source, which is 8 angle 30. So we can directly calculate 2J divided with 2J plus 9.6 minus 0.8J, then multiply with IS, which is 8 30, 8 angle 30, 8, press shift negative, then you get the polar angle 30. Okay, so change it into polar form, so you get 1.654 angle 112.87. So once you get I note, then we can remove this part and substitute with current source, which is I node, and this is 2 negative J4. So we need to calculate what is IA. So IA is equal to negative J4 divided with 2 minus J4 and then multiply with I node, which is this value. So again, negative 4G divided with 2 minus 4J and multiply with 1.654 112.87. So change it into polar form, then you get 1.479 angle 86.3 ampere. Okay. Okay, so for our previous problem, so let's say we need to measure what is voltage drop at ZC. So for this case, since the circuit consists of combination, series and parallel impedance, so we know that voltage at parallel circuit is equal. So in this case, ZP, voltage at ZP is equal to ZC. So if you want to measure what is V naught, so automatically V naught is actually measure at voltage drop of ZP parallel ZC. So V naught is equal to ZP parallel with ZC divided with ZA plus ZP parallel with ZC. Okay. And multiply with V. So let's say if this circuit, you have another one impedance connected parallel to ZC. So for this case, voltage drop at VC is no longer equal to ZP. Okay, but we know that ZC plus ZD and voltage at these two impedance is equal to ZP. So first step, you need to add these two impedance, so ZD plus ZC. So we need to measure what is voltage drop at these two, since these two impedance are now in parallel. So label as VA. So now we know that voltage in parallel is the same. So ZP parallel with ZD plus ZC in. Okay, so we have to calculate what is VA first. So VA is equal to ZB parallel ZD plus ZC divide with ZA plus ZB parallel ZD plus ZC. Oh, sorry. Multiply with V. Okay. So once you get the value, once you get VA, then you can actually calculate what is ZC. Okay. So now you already measure what is VA here. So now you can just ignore the rest part of the circuit. So substitute your source VA, then ZD and ZC, and you need to measure what is V naught. So V naught, so apply VDR again. So ZC divide with ZC plus ZD multiply with VA. So VA, substitute this value in here. Okay, so let's go through some example. Okay, so for this example, we need to determine what is V naught, voltage drop at 8 ohm resistor. So first step, you need to measure what is voltage at parallel. So let us label as VP. Oops. Okay. So to get VP, you have to simplify this impedance. So ZP equal to J4 parallel with these two, 8 plus minus J2. Minus 2J. So you got 1.882 plus J 3.529 ohm. Okay, so now you have ZP, then you need to calculate what is ZP using VDR, voltage divider rules. So VP is equal to ZP divide with ZP plus 2 divide with supply voltage, which is 10 angle 30. So ZP 1.882 plus 3.529 divide with 3.882 plus 3.529 multiply with 10 angle 30. So change it into polar form. 6.64 angle 56.06. Okay, and then once you get VP, so you can ignore this part and substitute voltage source at here. So this is VP, negative J2, 8. So you want to measure what is V naught. So V naught is equal to 8 divided with 8 minus J2 multiply with VP. So take this value, multiply with 8 divided with 8 minus 2J. So you get 6.44 angle 70.1. Okay. And let's say you want to use another method. Yep, you can. Okay. So let's say this is method 1. Method 1 we use simple VDR. VDR. Yep. And for method 2, yep, you can use CDR plus Ohm's law. Okay. So how to you need to calculate what is current at this branch. So we label as V naught, I naught, sorry. But first step, you have to measure what is I at this, which is we label as IS. So to calculate IS, you have to total up all the impedance. So Z total, and this is your, then you can calculate what is IS. So Z total is these two. First step, you have to series these two impedance. So 8 minus J2, and then parallel to with this impedance, so J4, and then add 2. Okay, so you can directly press your calculator and add 2. So we get 3.88 plus J 3.529 ohm, and calculate IS using Ohm's law, V over Z total. So 10 angle 30 divided with 3.88 plus J 3.529. So 10 angle 30 divided with, and change it into polar form, so you get 1.906 angle negative 12.2. 0.27. So once you get current flow at this branch, so you can simply ignore this part. So we replace with IS, then you have J4, and then negative J2, 8. So calculate I naught, I, and then determine what is V naught. Okay, so to get I naught, you need to use CDR. So J4 divide with J4 plus 8 minus J2 multiply with IS. So this is IS. So IS multiply with 4J divide with 8 plus J4 minus J2, so you get 2J. So 0.925 angle 63.69 ampere. Yeah. So final step, calculate V naught using Ohm's law. Okay, so by using Ohm's law, we know V is equal to I naught multiply with Z. Since we want to measure voltage at 8 ohm, so Z will be 8 ohm. Multiply with 8 ohm. So change it into polar. So you get 7.396 angle 63.69 volt. Okay, so you can compare your results with the previous method. It should be the same, so maybe there are some mistakes in calculation. So let us check again. So J4 parallel with plus 8 minus 2J inverse and inverse again. So this one is correct. Oops. Then next, ZP divide with ZP plus 2 and then multiply with 10 angle 30. So this one is wrong. So the value should be 7.624 angle 49.65. Okay, so next, calculate what is V naught. So multiply VP with 8 and then divide with 8 minus 2J. So you get 7.396 angle 63.69 volt. Okay, so both methods give the same results. So you can choose any method that you're comfortable, and make sure that you carefully calculate the value, because since we involve with complex number, so the tendency to perform an error in calculation is quite high. So make sure that you calculate using your calculator, and don't you have to perform twice to check. Okay, so that's all.